Alright, so right now we're going to work on Unit 3, Worksheet 4, question number 3. This is a kangaroo jumping to a height of 2.62 meters. Determine the takeoff speed of the kangaroo. So starting with my diagram, this is a good one for a diagram, and how a diagram can help you out. Velocity in meters per second versus time in seconds. And when this kangaroo jumps up in the air, leaving the ground, the kangaroo will be moving in the positive direction, because obviously the kangaroo is moving up to jump up. But over time, as the kangaroo moves up in the air, it will be slowing down. We know that during free fall, objects accelerate at a constant rate of negative 10 meters per second squared, and so the slope of this velocity graph is a negative slope. And this is going to be helpful later on, but for the time being, that's my diagram, and it looks pretty sweet. Known and unknown values. So the only given value here is the height, or the displacement that the kangaroo gets up to is positive 2.62 meters. So that's a given. It's not stated in this problem explicitly, but we have a kangaroo jumping. It'll be flying through the air, and that means that it is in free fall, and our acceleration is negative 10 meters per second squared. The last known value is not necessarily obvious right off the bat, but it's easy to see on my graph that when the kangaroo gets to its highest point, that maximum height, its velocity is going to be 0. And that's something that we know from when we discussed free fall in class. So again, it doesn't have to explicitly state that in the problem, because we know enough about free fall, especially objects being thrown up in the air. Think back to the ball toss lab. We know enough about free fall to know that the final velocity when an object is at its highest point is 0 meters per second. So the question asks us for what the takeoff speed was. In other words, it asks us to determine what the initial velocity is for this object. Now, looking at my variables, it's clear to me that there's something that's lacking here, which is that there is no time in my knowns. So that's a pretty good hint that I'm going to want to use our time-free equation, and that would be v final squared equals v initial squared plus 2a delta x. This equation doesn't have time in it. I know what final velocity is, I know what acceleration is, I know what displacement is. The only thing I don't know is initial, so one unknown means a solvable equation. So let's get down to it. V final squared, 0 meters per second squared is easy, equals V initial squared plus 2 times A, negative 10 meters per second squared, times our displacement, which is in this case positive 2.62 meters. The signs of these are very important. It's very important that you keep the sign correct so that my acceleration is negative, but my displacement is positive. And we'll see why in a second. Because this simplifies to 0 equals V initial squared plus 2.62 plus a negative 52.4, and the units there are meters squared per second squared. Now, when I continue to simplify this, I'm going to have to move this negative 52.4 to the other side. And that's important because that's going to make it positive again when I do the inverse operation. So I'll end with V initial squared equals positive 52.4 meters squared per second squared. Taking the square root of both sides and solving for this, I get V initial equals plus or minus 7.23, or let's say 24 meters per second. Right? When I square root my units there, the meter squared square rooted is a meter, second squared square rooted is a second. And last but not least, looking at this answer, only one of these can be correct, positive or negative. When I look back at my graph, I see that my initial velocity according to the graph was a positive velocity greater than 0, which makes sense because my kangaroo is jumping up. And that means I'm going to eliminate my negative velocity as a possible answer. And so what I'm left with is that the kangaroo's initial takeoff speed was positive 7.24 meters per second.